Okay, now let's start new lesson. That is about coordinate geometry. So this is geometrical thing. Now under coordinate geometry, we have especially basic coordinate geometry part. So I'm gonna do it today. And there's another thing that is about straight lines and circles. Two lessons. Then that straight line and circle altogether that contain part B 1 question and part A 2 questions. Then altogether 20% mark for pure mathematics. Okay, then that is very important section. But this coordinate geometry part very simple. Okay, now you consider, you know many things under coordinate geometry. Consider here, you consider a particle, then location of that particle, the position of that particle we can denote by geometry. Okay, so when you consider a real number line, so you consider here origin, then origin, so here displacement you say x, then there must be real value here. You consider two-dimensional plane, here one real axis, here another real axis. Usually we say this one x-axis and usually we say this one y-axis. Then when you consider point here P, then the position we can denote by x coordinate and y coordinate, no? Then here x comma y we call Cartesian coordinate. So here P x comma y. Then you consider here O, we say this is origin 0 comma 0. You know these things. Anyway, distance from the origin, let's say R, take this angle, anticlockwise sense measured angle from the positive direction of the x-axis, take this angle theta. This is we call Cartesian coordinate. Then further we can write P coordinate as r comma theta. P as r comma theta. We say that is polar coordinate. Polar coordinates. Okay, Cartesian coordinates and polar coordinates. Okay. Then here r comma theta, this is x comma y. And one another thing, this y coordinate we say, this is y coordinate, no? We say ordinate. Another name, ordinate. And here x we say abscissa. So y we call ordinate, x we say abscissa. Okay, y coordinate and x coordinate. Then this position we can say by x coordinate and y coordinate, and as well as length of distance from the origin and the inclination. Theta we call inclination. And r we call distance from the origin. So this is we say two-dimensional plane, 2D plane. And further we have 3D plane. You consider here, three-dimensional plane. Here x-axis, y-axis, z-axis. So it look like this, x, y, z. Then x, y, z. We need 3 coordinates to define point. So when you consider a plane figure, then 2-dimensional enough. But when we consider 3D figure, then we need 3 coordinates. So you take x here and you take y here. So here, then you take z here. Okay, so now it's like this. Then this plane, we can consider this plane. I'll take point P here, x comma y comma z. Here this one. So we need 3 coordinates. Here 3-dimensional plane. So we have to think small thing about 3-dimensional, but anyway we discuss everything under 2-dimensional things. Okay. So here real axis, then we say this is Cartesian plane. But there are some different axis system. Here real axis, there can be imaginary axis, we call complex plane or imaginary plane. So using vectors also we can take here I vector, j vector. Likewise there can be different axis systems, but don't worry about that for now. Okay, we will discuss everything. So under vectors, under complex numbers and all. So anyway, now you identify geometry, coordinate geometry, very simple thing. We discuss with point, we discuss with system of points, and we discuss with straight lines, and we discuss with circles. Likewise, those type of shapes. We specially call conic sections. So when you consider a cone, here a cone, you consider this is a cone. So here this point, vertex is a point, no? When you consider this edge, it is a straight line. So when you get cross section like this, then you see, we can see here a circle. When you get cross section parallel to this base, when you get cross section like this, so we can see an ellipse. Okay. So when you consider a cross section like this, we can see here parabolic shape. Here you consider a cross section like this, parabola. Likewise, we can get different sections. There we say conic sections. So these conic sections we can analyze with this type of coordinate geometry, 3-dimensional plane and 2-dimensional plane. But don't worry about this. We mainly discuss about straight lines and circles. So later we will discuss that. We have one section called straight line, another section we call circles. Okay. But for now I'm going to discuss about Cartesian plane and some relations with points and some relations with gradients. Those are the things. Okay, just write topic. Coordinate geometry. Very simple, small lesson. Na? This part very simple and small lesson. Coordinate geometry. Okay, just write. Under this section, we mainly focus on a geometrical relation, and corresponding algebraic relation. There are few theorems. Are given below. Okay. Here this is 1D, one dimensional. This one 1-dimensional, here 2-dimensional, that one 3-dimensional. Okay, we mainly focus on 2-dimensional one, but anyway you sketch this one 1-dimensional and 2-dimensional one. Write this name very important. I think you don't know this. This is abscissa, and this is we call ordinate and abscissa, new name. Okay, just sketch them. Okay, you better to sketch these diagrams again, but don't worry about everything. This three-dimensional, here this is conic sections. Conic sections. We have different sections, huh? Circle, straight line, ellipse, parabola, and there's another one, hyperbola. But don't worry everything, but just sketch one of them, a few of them. Okay, now check it again. X coordinate we call abscissa, y coordinate we call ordinate, and here Cartesian coordinate x comma y. So we need horizontal and vertical displacements. Cartesian coordinate. Here polar coordinate, we need distance from the origin and the inclination of that. Here we call inclination. So inclination we take positive direction of the x-axis, anti-clockwise sense measured the angle, not clockwise, okay, anti-clockwise. So if you see some point somewhere here, then you sketch this line, and from this positive direction of the x-axis you have to measure full angle, not clockwise angle. So if you see point somewhere here, you sketch line segment and start from here, measure full angle. Okay, that is inclination. Okay, now you write these things with me, you know everything, but there are few small definitions I'm going to discuss. Okay, write with me. Here this is Cartesian plane, x-axis positive direction, y-axis positive direction, x-axis negative, y-axis negative direction. Here origin coordinate we say 0, 0, we denote by O, and here this is O. There's another thing, this coordinate 0, 0. So we have another one thing, absolute 0. Later we will discuss that. So this is 0, 0 coordinate. Okay. Then here this one we say first quadrant. Quadrant, write with me. Second quadrant. And here third quadrant. And here fourth quadrant. So you consider here point P, let's say variable point x comma y, so that varies with theta. So first quadrant we know x, y both positive. Second quadrant we know x negative, y positive. And third quadrant we know x, y both negative. And fourth quadrant we know x positive, y negative. So we know these things. Just write. Here P. Theta inclination. Inclination of OP. OP. Then tan theta value, tan theta we say gradient of 4p, gradient of 4p. Gradient of OP, generally we denote by MOP, MOP, gradient of OP. Just theta inclination and tan value gradient. Okay, just sketch with me. Okay, now you come to this, sketch with me. So gradient we usually denote by m. So n can be 0, m0, m special 1, m positive special and m negative special. Then 0 gradient, sketch with me, parallel to x-axis, 1 gradient, 45-degree inclination. There's another one, m infinity case. So let's sketch this too. Positive gradient, acute angle, the angle theta, theta 0 to 90 degree. Here negative gradient, obtuse angle. Here this angle theta, m 90 to 180. Okay. Here we have m infinity case as well. Okay, we have m infinity case as well. I'll sketch here. M equal infinity. So here parallel to y-axis. Here infinity gradient. Theta 90 degree. Here theta equals 0. Here theta equal 45 degree. That goes like that. These are gradients. Just sketch. Huh? Okay, check this one again. Here, this point x comma y, x coordinate we say just x, that can get positive and negative value. But here this length we say modulus x. Here this length modulus y. Then OP length modulus x squared plus modulus y square root by the Pythagorean theorem. Then modulus x square mean x squared, modulus y square mean y squared. Modulus represent only length. Then OP length, finally we write x square plus y square whole thing root, that we call distance from the origin. Then theta inclination, tan theta gradient. Then tan value y divided by x. Y of x is MOP, gradient of OP. Okay. Write it. Okay, you can apply those relations directly, okay? Now you do with me these examples, do with me. P equal 3,4. Therefore, OP equal 3 squared plus 4 square root. It is 5. OP mean length, no? Then there can be unit. Then you write here units. 5 units. Can be centimeters, meters, kilometers, whatever it is, okay. You put units. Then MOP, gradient of OP, we know that is y of x, no? Then y coordinate 4, x coordinate 3. Then here gradient, we don't have unit here, no? For gradient, here distance, we cancel and no units. Then for gradients, no units. But for displacement, we have, no? Then take P point minus 5, 12. Then OP, you just write 5 square plus 12 square root. Forget sign. Then it is 13 units. Write it, do with me. Then MOP, y of x, 12 over minus 5. 12 over minus 5, no? So we don't have any units here. Do with me. That means you can apply those relations directly. P minus 3, 4, OP equal 3 square plus 4 square root, 5 units. MOP minus 4 or minus 3, 4/3. Here we have to consider sign, here gradient. Fourth one, P 2, 3, then OP 2 square plus 3 square root, here 9 root 13 units. Then MOP 3 over 2. Then all the other things are same, no? Only coordinate will change. Okay, then that is very simple thing. You can apply these theorems directly. Now let's move further a little. Okay, now sketch with me. Previous one coordinate, no? Now we have 2 coordinates. Here take x-axis, y-axis. Take here point P, x1, y1. Take here point Q, x2, y2. Okay. So here I'm going to deal PQ length. Here this coordinate x1, this coordinate x2, then here distance x2 minus x1 modulus, and here coordinate y1 according to my diagram, here this coordinate y2, here distance y2 minus y1 modulus. Then you can write y2 minus y1 or y1 minus y2, whatever it is, okay. We put modulus sign now. Then take this angle theta, that is inclination again. Then PQ displacement, PQ distance, PQ. So you can get Pythagorean theorem for this, no? Then x2 minus x1 square, y2 minus y1 square root. Then x2 minus x1 squared, y2 minus y1 square root. The distance between 2 points. Then here theta inclination, tan theta gradient, tan theta m pq. We say y difference over x difference, y2 minus y1 over x2 minus x1. So if you start second coordinate, that means y2 minus y1, then denominator again you start with second one, okay? x2 minus x1, otherwise sign will change. Or y1 minus y2 over x1 minus x2, that also possible. So that is gradient of 4p. Okay, write with me. Gradient of PQ. These things you can apply directly. Okay, here this one we say usually distance formula, okay? Distance formula. This is distance formula, distance between 2 points. Previous one again distance formula, distance from the origin, no? Distance from the origin. Okay. Now same time let's do few examples. Here PQ points given, then PQ length, x difference square, 3 minus 2 square plus y difference square, 4 minus 5 square root. Then here 1 root 2 units. Here 1 square 2 root 2 units. MPQ, y difference of x difference, 4 minus 5 over 3 minus 2. So we get 1. Okay, do with me. P equal 4 minus 1, Q equal 3 5. 3 minus 2. Then PQ length, x difference, 4 minus 3 square, minus 1 minus 2 square, x difference square plus y difference square root. Here 7 square and here 1 square, root 50 units. here 1, here 7. Then MPQ, y difference of x difference, -1 minus minus 2, put signs properly, 4 minus minus 3. Then here 1/7. That's how we write, okay? Do with me. You can apply these theorems directly. Distance formula, we can apply it directly. P 1 5 Q 2 minus 3 3 P minus 3 minus 2 Q minus 5 5. Okay, you do. Here PQ 1 minus 2 square, 5 minus minus 3 square root. Here 8 square, 64 plus 1, 65 root units. Then MPQ, y difference 5 minus minus 3, 1 minus 2, minus 8. Minus 3 minus minus 5 square, minus 2 minus 5 square root. Here 2 squared plus 7 squared. Here 49, 53 units, root units. 7, 49, here 2, no? MPQ, minus 2 minus 5, minus 2 minus 5, minus divide by minus 3 minus minus 5. Y difference of x difference. Here minus 7/2. Here minus 7/2. Now let's come to section formula. Section formula. See this. Here 2 points given. So you consider here midpoint. Here section 1:1 ratio, no? Midpoint. Then here this coordinate x1 plus x2 over 2 no? x1 plus x2 over 2. And similarly here, y1 plus y2 over 2. Therefore, midpoint x1 plus x2 over 2, comma y1 plus y2 over 2. Okay, put it. That is section formula. Then you consider P 1, 4, Q 2, 3. Then midpoint 1 plus 2 over 2, 4 plus 3 over 2. 3 over 2, 7 over 2. P minus 1, 4, Q 2 minus 1. Then midpoint minus 1 plus 2 over 2, 4 minus 1 over 2, 1 over 2, comma 2. 1, no? Likewise, you can directly write section formula. Here midpoint. Section formula midpoint. Okay, now see another one. Now see another one. Now midpoint previous one. Now section formula, any section. Check this one all. Here this point you say that is given, Q point given. So M is to N internal division point is R. PR to RQ, M is to N internal division. Internal division. So here we can write R directly. Check this pattern first. Check this pattern first, okay? So R coordinate, we have two, no? X and Y coordinate. X coordinate deals with X only. And Y coordinate deals with Y only. And here M related with this one, P and R. N related with R and Q. You multiply M with non-related one and N with non-related one. So here the pattern, mx2 plus nx1 over m plus n. Check it again, mx2 plus nx1 over m plus n. Similarly, y coordinate my2 plus ny1 over m plus n. my2 plus ny1 over m plus n. You remember the pattern. X coordinates comes with x coordinate, y coordinates comes with y coordinate. So you multiply m with non-related one, mx2 plus nx1 over m plus n. Similarly, my2 plus ny1 over m plus n. Here this is internal division point. Okay, put that one, then we can do examples. Now let's do few examples. Okay, take this question. You better do with me. See the pattern now. Here P 1, 2, Q 3, 4, and here R ratio 5 to 6. PR is to RQ 5 to 6. Check this one. Okay, then check this one. 5 times 3. Here R coordinate 5 times 3, 6 times 1, 6 times 1, and then 5 plus 6. So according to that pattern you apply, okay? 5 times 3 plus 6 times 1 over 5 plus 6. Then y coordinate 5 times 4 plus 6 times 2, 5 plus 6. Then you can simplify, no? 15, 21 over 11, 32 over 11. Likewise, you can directly get section. Okay. Do another one with me. Do another one with me. Here point P minus 1 comma 2, point Q 0 comma 3. Here R 2 is to 1. Then R point, you do this, say 2 times 0, 1 times minus 1 over 2 plus 1, 2 times 3 plus 1 times 2 over 2 plus 1. Then here minus 1 third, 8 over 3. Continue. Now you try another 2 questions. You try another 2 questions. Okay, you do alone. Here P 1 5, Q 2 3. Here 3 is to 2 ratio R. P minus 1 2, Q 3 minus 1. Here R 5 is to 4. Okay, do soon. Do soon. Okay. Here 3 times 2 minus 2 times 1, 3 minus 2. 3 times 3, 2 times 5, 3 minus 2. Then 6 to 4, 9, 10 minus 1. Okay. Then here R 5 times 3. Here not minus, no? Plus 8 over 5. 8 over 5. 19 over 5, no? 19 over 5. Okay, here 5 times 3, 4 times minus 1. 5 plus 4, 5 times minus 1, 4 times 2, 5 plus 4. 11 over 9, 5, 8, 3 over 9. 11 over 9, 3 over 9. Okay. Okay. Now let's see one another theorem. So previously I discussed about internal division. Now this is about external division. So these theorems you can apply directly. When you are doing questions, you can apply directly. Okay. Now here external division, take here P x comma y, x1 comma y1, take here Q x2 comma y2. See this one all clearly. So I'm going to extend this one up to here, let's say R, then P R M Q R N. Then here P R is to Q R, M is to N, external division. So later we can prove them. See this one all. Here M to N, these 2 points given, then it has extended here, M is to N, M greater than N. Now see R point, external division, you do this way. So M directly connected with P and R, no? Then here unrelated one. Then non-related one. N connected with Q and R, here the non-related one. Then likewise previous format, you multiply M with non-related one, M x2. Here N x1. Likewise you do M multiply with non-related one and N multiply with non-related one. M x2, N x1. Here put difference over M minus N. Previously we put plus, no? Now here difference. Then do same thing, my2 minus ny1 over M minus N. That is our format, okay? Again check it. M multiply with non-related one, mx2 minus nx1 over M minus N. Here M, then you go to M here. Then y coordinate also same, my2 plus ny1 over M minus N. That is our format. You can apply directly these sections. Here external division formula. Okay, put that one. Okay, let's do 2 examples. You do with me. See the pattern. Here P, 1, 2. Here Q, 3, 4. Here R. Here 3 to 2 external division. Then you do this, say 3 times 3 minus 2 times 1, 3 minus 2. 3 times 4 minus 2 times 2, 3 minus 2. See the pattern again. Here 3 multiply with non-related one. 3 times 3 minus 2 times 1. Now simplify. 9 to 7. 12 for 8. Do with me. P minus 1, 2. Here Q, 3, 4. Here R. Here 4 is to 1 ratio. 4 is to 1 ratio. Then R 4 times 3 minus 1 times minus 1. 4 minus 1. 4 times 4 minus 1 times 2. 1 times 2. 4 minus 1. 13 over 3. 2 over 3. 2 over 3. Continue. Finally, you do these two questions. P 3, 4. Here Q 1, 5. R 4 is to 3. Okay, you do alone. 5, 2. Q 3 minus 1. Here 2 is to 1. External division. Okay, just do them. Just do them. Okay, something wrong here. 4 times 4 times 4. 14 over 3, okay? 14 over 3. Here, 14 over 3. Okay, continue, do soon. 4 times 1 minus 3 times 3, 4 minus 3, 4 times 5, 3 times 4, 4 minus 3. 2 times 3, 1 times 5, 2 minus 1, 2 times minus 1, 1 times 2, 2 minus 1, 6, 5, 1, minus 2 minus 2 minus 4. Okay, now we have fully completed section formula and distance formula. Section formula, distance formula. So we have to do few more questions, no any other theorems. So under coordinate geometry theorems all over now. Okay, then next day we can complete more questions, we can do more questions, then we can complete the lesson. Okay, that's enough for today.